Reduce the equation 3uxx plus 10uxy plus 3uyy equals to 0 to a canonical form. Solution: the given equation is 3uxx plus 10uxy plus 3uyy equals to 0. Equation 1. Comparing equation 1 with the general second order partial differential equations auxx plus buxy plus cuyy plus dux plus euy plus fu equals to g. We have a equals to 3, b equals to 10, c equals to 3, d equals to e equals to f equals to g equals to 0. Now the discriminant b square minus 4ac equals to 10 square minus 4 into 3 into 3 equals to 100 minus 36 equals to 64, which is greater than 0. Hence the given equation is a hyperbolic partial differential equation. Then corresponding characteristics are dy over dx equals to minus eta x over eta y equals to minus b plus square root of b square minus 4ac upon 2a equals to minus into minus 10 plus square root of 10 square minus 4 into 3 upon 2 into 3 equals to minus into minus 10 plus 8 upon 6 equals to minus into minus 2 upon 6 equals to 1 upon 3. Equation 2. And dy over dx equals to minus neta x over neta y equals to minus into minus b minus square root of b square minus 4ac upon 2a equals to minus into minus 10 minus square root of 100 minus 36 upon 6 equals to minus into minus 10 minus 8 upon 6 equals to 3. Equation 3. To finding the eta and neta for the integrating equation 2 and 3, we get y equals to 3x plus c1, which implies c1 equals to y minus 3x, and y equals to 1 upon 3x plus c2, which implies c2 equals to y minus 1 upon 3 into x. So eta equals to y minus 3x equals to c1, and neta equals to y minus 1 upon 3x equals to c2. These are the characteristics lines for the given hyperbolic equation. To finding the canonical equation, now the desired transformation are eta equals to y minus 3x and neta equals to y minus 1 upon 3x, here eta x equals to minus 3, eta y equals to 1, eta xx equals to 0, eta xy equals to 0, eta yy equals to 0, neta x equals to minus 1 upon 3, neta xx equals to 0, neta xy equals to 0, neta y equals to 1, neta yy equals to 0, so that we have form equations a bar equals to eta x square plus b into eta x eta y plus c into eta y square. B bar equals to 2a eta x neta x plus b into eta x neta y plus eta y neta x plus 2c eta y neta y, and c bar equals to a into neta x square plus b neta x neta y plus c neta y square. We get a bar equals to 3 into minus 3 square plus 10 into minus 3 into 1 plus 3 into 1 square equals to 27 minus 30 plus 3 equals to 0. B bar equals to 2 into 3 into minus 3 into minus 1 upon 3 plus 10 into minus 3 into 1 plus 1 into minus 1 upon 3 plus 2 into 3 into 1 into 1 equals to 6 plus 10 into minus 3 minus 1 upon 3 plus 6 equals to 6 minus 100 upon 3 plus 6 equals to 18 minus 100 plus 18 upon 3 equals to 64 upon 3, and c bar equals to 3 into minus 1 upon 3 square plus 10 into minus 1 upon 3 into 1 plus 3 into 1 square equals to 3 into 1 upon 9 minus 10 upon 3 plus 3 equals to 1 upon 3 minus 10 upon 3 plus 3 equals to 1 minus 10 plus 9 upon 3 equals to 0. Also d equals to a eta x plus b into eta xy plus c into eta y plus d into eta x plus e eta y equals to 3 into 0 plus 10 into 0 plus 3 into 0 plus 0 plus 0 equals to 0, and a bar equals to a into neta x plus b into neta xy plus c into neta yy plus d into neta x plus e into neta y equals to 3 into 0 plus 10 into 0 plus 3 into 0 plus 0 equals to 0. F bar equals to 0, G bar equals to 0. Now putting the value of A bar, B bar, C bar, D bar, E bar, F bar and G bar in the A bar equals to U eta eta plus B bar U eta neta plus C bar U neta neta plus D bar U eta plus E bar U neta plus F bar U plus G bar, we get 0 minus 64 upon 3 u eta neta plus 0 plus 0 plus 0 plus 0 equals to 0, which implies minus 64 upon 3 u eta neta equals to 0. Which implies 64.3 u eta neta equals to 0, which implies u eta neta equals to 0, which is the required canonical form. Now to find the solution of the canonical form, integrating, we get u eta neta equals to f eta plus g neta, where f and g are the arbitrary. Hence the original equation has a solution u of xy equals to f of y minus 3x plus g of y minus 3x, because eta equals to y minus 3x and eta equals to y minus x upon 3.